Hello everyone. Today we'll perform uh, design and test biased clippers. Experiment number 3. Biased clipper. The first one positive biased clipper, negative biased clipper, and positive negative biased clipper. So the first one parallel biased positive clipper. The circuit diagram. Diode is in parallel with input as well as in output. We have a load resistor here RL and a DC supply VB. The input supply is AC sine wave. This is the input supply, and this is the output waveform what we get. We can see the positive, some portion of the positive half cycle is clipped off. We are getting only the dashed line, the solid line, sorry. We'll get the solid line at the output, and this dashed line is clipped off, means removed. The operation, what happens here during the positive half cycle, you can see when the positive half cycle comes across the secondary here, terminal A becomes positive and this becomes negative. As this is positive connected with positive terminal of the diode, which is anode, positive and positive, diode is forward biased. Whereas here positive connected to negative, this DC supply will make the diode reverse bias. Okay. So there are two scenarios. When the positive half cycle comes here, due to the input supply, diode is forward biased, but due to the DC supply what we are providing here, this is what is called as biasing. The name of the experiment is biased positive clipper. Biasing means we are providing an external supply to this diode. We are connecting an external supply to this diode. So here this supply VB is making the diode reverse biased. So what happens during the positive half cycle? The diode is forward biased by the input supply voltage VI and reverse biased by the battery voltage VB. Okay. So what happens? The input supply voltage VI is less than the battery voltage VB initially. See, initially the input supply is less than VB. In our experiment, what we have considered VB to be 5 volt and VI maximum to be plus 10 volt. Okay, so VB is a DC supply, which means 5 volts constant will be there. So initially VI should increase from 0 to 10. Okay, so up to 5 when the input supply is there, in that case input supply voltage is less than the DC supply voltage. Okay. So in that case what happens? VB dominates VI, therefore diode is reverse biased and this circuit becomes open circuited. When the diode is reverse biased, this becomes open circuited, therefore output will appear across output, input will appear across output, therefore you will get the solid line. It means that up to 5 volts you are getting the output, but after 5 when the input is increased above 5, what happens? The diode dominates VB, therefore the diode is forward biased. Sorry, when input is above 5 volts, input voltage dominates VB, therefore diode is forward biased, and when the diode is forward biased, it is short circuited, therefore we will not get any output here. Okay. So therefore you will not get output above 5 volts. This happens when the positive half cycle comes across this terminal. In the second case, when the negative half cycle comes here, A becomes negative and B becomes positive. Negative terminal connected to positive, diode is reverse biased, as well as positive connected to negative, diode is reverse biased. In both the cases, diode is reverse biased with respect to input as well as with respect to the DC bias voltage. The diode is reverse biased. When it is reverse biased, it is open circuited and output is there. Output is present. It means input is supplied to the output. Therefore, you will get a complete negative half cycle at the output. This is parallel biased positive clipper. In parallel biased negative clipper, we will reverse this diode as well as we will reverse this DC supply. Okay, the operation remains same. When the positive half cycle comes here, A is positive, B is negative, positive connected to negative. During the positive half cycle, A is positive, B is negative. Positive connected to negative, diode is reverse passed. And with respect to this DC, negative connected to positive of diode, again diode is reverse passed. With respect to DC as well as with respect to input, diode is reverse passed. Therefore, it is open circuited. Input appears across output. We will get this positive half cycle appearing across the output. In the second case, when the negative half cycle comes across VI, A becomes negative, B becomes positive. When A is negative, negative connected to negative, diode is forward biased. But with respect to DC supply, negative connected to positive, diode is reverse biased. Therefore, initially, when input is less than 5 volt, we will get the output waveform. But after 5 volt, the diode is short circuited and it will not allow any output to flow across the output terminals. Right? So this is about parallel bias negative clipper. The third one, dual, that is combination clipper, means both positive and negative. The third one, here we will combine the circuit. We'll combine the positive clipper and the negative clipper circuit, so that when positive half cycle comes, the positive portion, some portion of the positive half cycle is clipped off here because of this circuit, and because of this circuit, some portion of negative half cycle is clipped off here. We'll perform the same in LTSpice. New schematic. We need a voltage source, a resistance, a diode, and rotate this, the battery, DC source. Let me connect these components. Provide a ground for this. Let me specify the values. So before specifying values, let me name this as VI, means input source. Let me name this as RL. This one as VB. Specify the values. Go to advanced. Select sine. Amplitude of 10 volt. Frequency of 55 hertz. And RL, let me select it as 1K. Diode, we pick the first one, 1N914 with voltage breakdown of 75 volt. Voltage breakdown of 75. Then DC biasing voltage, I will specify it as 5 volt. Right. This is the okay. All right. So now the direction of diode is correct. So this is a positive biased clipper. Let me run this. Okay, specify stop time 0.05. Okay. We'll have two plot panes. This is for input and this is for output. All right. So this shows some portion of positive half cycle has been clipped off. All right. So this is called as a parallel positive biased clipper. The negative half cycle, we are getting a complete wave, but positive half cycle after 5 volt, this portion is clipped off. For parallel negative biased clipper, we'll rotate the diode as well as this VB. And to do so, Let me run this. Again, two plot panes, one for input and one for output. You can see below this minus 5 volt, this portion is clipped off. But the positive half cycle, we are getting a complete half cycle. So this is the second one, negative clipper. And the third one, and for the third one, we'll simply add a diode here and a battery. You connect these components, you specify. Okay, let me take this side. Okay, let me change the name of this as VB1 and this as VB2. Diode, same diode, we'll select. Okay, which voltage is 5 volt. Solid. Now let me run this. All right. We can see when we combine these two circuits, then after 5 volts, we are not getting this portion, and below 5 volts, we are not getting this portion. This is input and this is the output. Thank you.